Welcome to another video as part of the Tech Tuesday series where we are looking at the various technologies, processes, machineries which are out there to process waste. In the previous Tech Tuesday video, we saw the 8 R's of trash technology, especially the raw material. And in today's video, we are going to look at the second R, which is nothing but the resource. I am Praveen Kumar, the creator, educator at Thrash the Trash, an online learning social platform for you to create an impact or income in waste management. Let's get into the video. Let's have a quick recap of what we saw in the earlier video. In the previous Tech Tuesday video, we saw about the raw material selection, which is nothing but the selection of a particular waste type or a category. So how you can do it. And then we saw the quantity, the quality, the input form in terms of the raw material availability and the machine's capacity, and we discussed the various factors pertaining to raw material. Now we are going to look at the resource. So what are the resources required to perform the action or activity which is nothing but processing of waste? Let's go one by one. First, let's look at in terms of the process, technology or machinery. Number one, which stage is the technology, process or machinery in? Is it in the early stage, a proven stage, or is it an outdated one? When we say early stage, that means that whatever is a technology, process or machinery, it is still under research and development. It is yet to get commercialized. Any technology, what you're seeing now, even it is proven or outdated, once it would have been in the early stages. You cannot say just because it is in the early stage, it's a bad choice. It cannot be the case. Some of the bigger corporations, conglomerates, they go for early stage technology to test it out, how good it is. So they spend millions of dollars in terms of the pilot experiment. Are you ready to take such a risk to go with the early stage? It's going to be up to your risk appetite. If not early stage, what about the proven one? When we say proven one, that means whatever is a process, technology or machinery, it has a solid performance. If not a solid performance, might be a decent performance. Why I changed from solid to decent? Let me tell you why. No offense. Whatever technology, process, machinery that we see today, where do you think it mostly originated? Mostly from the developed nations. It's not because they have smart minds, but also they have a lot of financial backings, which is generally not available in developing and undeveloped nations. So because of that reason, they are able to burn a lot of money in research and development innovation. So that gave them an upper hand. So they started developing technologies and then they make it commercially successful. It became a proven technology, and later from there it traveled, cascaded to lesser developed countries, then to developing, and then the undeveloped nation. But during this transition, what happened is that some of the countries like China, who are known for offering competitive but cheap machineries, what happened is that to reduce the cost, to keep it more attractive, what they did is that during the transition, more and more of the accessories, the add-ons which are required in terms of the performance got removed, and some of the know-hows got lost in the transition. So from a solid performance, it went to a decent performance, and especially with the Chinese machine, it went to a further low level. That is what is happening. So whatever is going to be a choice of your technology, you have to do with utmost care and diligent planning. And one more risk is there with the proven technology. If it is not your technology, and let's assume that you're going to buy it from someone, some organization, some supplier, some manufacturer, then there is a very high chance that somebody else also might be able to buy the same machinery. But then again, you need not panic. Depending on the capacity, they may or may not be a competition, or they may or may not be able to influence your business or your profit margins. You need not worry. Waste is a huge market. Even though it is a proven technology, more and more people can get into the business. If more and more people are able to come into developing or undeveloped nation, what is going to happen? That means more and more waste will get streamlined, channelized towards such companies, such infrastructure. So basically it is moving away from the informal sector and moving towards the formal sector. You can think in a positive way. Let's look at the outdated ones. Outdated in the sense it is an old technology, process or machinery, and it is no longer relevant at this point of time. But you need to ask this, whether all outdated ones, has it become irrelevant at this point of time? Need not be the case. It might become outdated because of the regulation, the legislation, or might be the technology, process or machinery. It has been classified as outdated, but then it is still relevant, it is still working. It is able to process the waste and give the necessary output. But because of the pollution norms, maybe it might be emitting so much of pollution, it is creating some other problem. So because of that reason, that particular technology might have been classified as outdated. So if you're going with such outdated technology, you should understand wherever you're going to put up that machinery, will that local regulation permit? Then you can take the decision according to that. This is something that you have to bear in your mind. Just because the technology is coming cheap and you don't know whether it's an outdated technology or proven technology, and later if you come to know that such technology is not allowed because of the current environmental regulation, then what is going to happen? So these are the factors that you need to consider. Coming to the next aspect, what kind of input can the machine take, the process or technology? Can it accept single input or multiple input or mixed input? When I say single type, that means it can accept only one type of waste or one category. So what is it going to be? Single waste type or only a single category within a waste type? When I say waste type, I'm referring to plastic. Within plastic there are ABS, LDPE, HDPE, PET, single-use plastic and so on. Now the question is it going to be a single waste type or a single category within the waste type? Or it could be multi-type, where it can accept multiple categories, but not at once, not in a mixed form, but rather you just need to change the configuration and then it will be able to accept it, but in a separate batch. Is that the case? Or it might be a mixed type, where the machinery, process or technology can accept waste in a mixed form. Generally, I used to say in my previous videos, on all videos, that what you feed in is what you're going to get out. If you're going to give mixed input, mixed type of waste, your output might be mixed unless until the machine is doing something special. It might be doing a segregation, sorting, or some special process to separate the outcome. So what is it going to be? Capacity. What is going to be the capacity of the machine? Earlier we saw the machine capacity is going to depend on the raw material availability. So now, are you going to go with a smaller capacity, medium capacity, large, or a super large? So what is going to be your choice of the capacity? Don't think that by going small you are trying to reduce your risk. It need not be the case. Going smaller means the question comes is, will you be able to recover your cost? Will you be able to make profit? Going super large means, will you be able to procure that much raw material? That is what we saw in the previous raw material Tech Tuesday video. So what is going to be your choice? It has to be somewhere an ideal one, but a well calculated one. And once you have fixed it, you won't be able to change. Once you got the machine and got it installed, you have to change a lot of other factors, paperwork, then only you will be able to increase or decrease the volume. What about the nature of the machine technology or process? Is it semi-manual, semi-automatic, or fully automatic? When we say semi-manual, it's going to be mostly manual work, but instead of primitive tools, we are going to use some pneumatic tools or electric tool, which is going to save time and effort when compared with a fully manual process. You might have a conveyor system for material movement, but then rest of the effort that goes into processing, it is done manually. Is it going to be semi-automatic? It's slightly above semi-manual. The investment is going to be higher. You're going to have a single machine or a series of machine which is going to aid in the waste processing. But again, it is not 100% automated. There will be requirement for workforce. the human intervention has to be there. Then only the semi-automated machine will be able to function. Otherwise, it will have a problem. The human intervention might be in the form of feeding the machine or moving the material from one machinery to the other machinery. It might be in the form of a sorting, a supervision, removal of certain unnecessary, unwanted waste. Or is the machine fully automated, where you may have to feed or you need not feed the machine, whatever might be the case, but whatever is the activity, the processing, it is done, it is taken care fully by the machine itself. You feed, it is going to give you the output, whatever is the desired output. But then fully automated is going to cost you so much of money, because it is going to be super expensive. It always comes with a minimum capacity. Now the question comes is, will you be able to procure that much material to meet the machine's capacity? One end, it's super expensive, there is a minimum capacity. Will you be able to procure and get your return on investment? So what is going to be, especially in country like India, where 90% of the waste is controlled by the unorganized sector. The same is more or less applicable for developing and undeveloped nations. This is something that you have to bear in your mind. Whatever terminology I'm using over here, these are not hardcore accurate terminology. The reason being is that if I start using technical terms, it may be difficult for a lot of people to understand. To keep it simple, for better understanding, I'm using very simple layman terms. Let's look at the next one. In terms of the complexity, whatever is the process, technology or machinery, is it going to use a simple process, or is it going to be a continuous process, or is it going to be a batch process? When we say simple, you feed in 1 or 2 steps, it's going to give you the output. Or the process might be a very lengthy process, more and more time, effort, various steps are involved. But in a continuous process, what is going to happen? The whole, from starting to ending, it's going to be taken care of by the machine or by the process itself. So continuously it's going to run, operate. Is that the case? Or is it a batch process, a step-by-step process? You feed in, an action was done on it. The first batch you feed, right? The first batch might take 1 hour. It gives the output, 1 or more output. Whereas then it goes to the subsequent process. One might take one machine, the subsequent machine, one machine might take half an hour. Whereas the other machine, depending on the input, it might take 3-4 hours. And then as it goes, the quantity, the input quantity, the batch time, the effort, the nature of operations, the output, everything is going to change. It's all going to depend on the previous process. So this is what we call the batch process. In a continuous process, it's going to be the same, but the machine itself will take care of all those timing, the parameters, the factors and everything. But in a batch process, what is going to happen? If it is not fully automated, then what is going to happen? Manual intervention is required. You feed the first machine, it gives, let's say, 2 or 3 outputs. You take the output, feed it to the next machine. Again, each will have its own time, duration, effort, monitoring. Then once it's completed, it goes to the next machine, and then the cycle continues. So what is the complexity level? Is it a simple, a batch, or a continuous one? This is about in terms of the technology. Think about it. Let me put everything in front of you in a single image. Capacity, small, medium, large, super large. The nature, it could be semi-manual, semi-automatic, automatic. Complexity, it could be simple, batch, or continuous. Look at this. Your machinery, process, technology, it could be in any of the permutation and combination. It may not be one set of choice. It could be more than one. So accordingly, all other factors, parameters will vary. So you have to do your due diligence in terms of this permutation and combination and see what are the risks, your cycle time you have to calculate, your workforce and all those factors. We will see one by one. Now this is about the machinery. We saw the raw material, then we saw the technology, process or machinery. Now let's look at the infrastructure. Where are you going to put the machine? Think about this. Your machine could be a small machine, a simple machine, or your machine could be a very gigantic machine, a series of machine. It's going to run from one end to other end. Whether it is small or big or super big, so where are you going to put these machineries. Are you going to put it on a rented space, or you're going to build a brand new building as per your requirement, and then are you going to host this machine over there? So what is it going to be? If it is going to be on the rented space, rented building, then you are reducing your capital investment. But then the question comes is, will you be able to take all of these machinery? If it is big, will you be able to take it inside and install it and commission it? If it is small, it is not a problem at all. On the other hand, if you're going with your own building, it's going to take time for you to construct from the scratch, set everything. On top of that, you have to bring the machine and installation. Whereas in rented space, it's just the modification required if needed, and then you just have to install the machine. Only the installation time is required when it's a rented space. So what is it going to be? Each has its own pros and cons, so do your homework properly. To host this machine, what is the area that is required? So accordingly, you will decide the area bifurcation, area allocation. This area for this machine, this area for this machine. It will be arranged in a sequence. It could be on the same floor, or it could be multi-floor or multi-story, again depending on the nature of the technology, process or machinery. So accordingly, all the built-up area, the height of the building and everything will be factored in. How about the area that is required? One, it is for the machine. We have seen, depending on the machine size, the sequence, the built-up area will be decided. But not only that, you have to have storage for your incoming raw material. Let's say every day your processing capacity is 10 tons. It doesn't mean that you will store only 10 tons of material in your premises. You will try to have stock, maybe at least for a week time, for 10 days, 15 days. So that much of space you might require, again depending on from where you are sourcing your raw material availability. This is for the incoming raw material, the storage space. And once your process is going to give you the output, again depending on the nature of the output, you might need to store it. Again, that also might require space. So factoring all this, you will consider your infrastructure. But there is more to it. Whatever is the technology, process or machinery, that is going to be your core machine, that is going to be the heart of your operation, your process. But do you think only that core machine will be enough to run your operation? You might also need some additional tools, accessories to effectively, efficiently run your operations. It might be in the form of a lift to move the material from one floor to other, or you might need a conveyor system, a forklift, a pallet jack, a trolley for the material movement. You might require a compressor for certain machines to operate, maybe a baling machine for the volumetric reduction. Depending on the nature of the operations, you might even require a power backup. In some cases, what might happen is your operation requires continuous power. Maybe if there is a sudden power cut, it may affect the process, which in turn is going to affect the output. Again, this is going to depend on the type of technology, process or machinery. What kind of power backup do you require for, and for how much duration? So all of this is going to be the additional tools or resources that you might require for an effective operation. We will see more. Think about from the compliance point of view. We talked about the machinery, but so far I haven't talked about the pollution norms. Even in waste processing, it will generate some form of emission, air, water, noise, whatever it might be. So you need to have appropriate measures to take control of these factors: air pollution, water pollution, noise pollution. Now the question comes, is it part of the machinery or is it going to be separate? So what is going to be the costing? What are going to be the emissions? So accordingly, everything will be decided. How about firefighting? Again, it's going to depend on the raw material type, your capacity, your nature of operation, your process, your built-up area. So accordingly, the firefighting will come into picture. There are many more when it comes to infrastructure. You might need to have a hazardous waste storage room. Again, depending on the type of waste that you're going to process, your capacity, your investment, lot of other factors. According to all of that, your compliance rule is going to get decided. Please don't tell me that whatever I'm saying in a very generic context when it comes to recycling, re-engineering, dismantling or TSDF as per the regulations. Just because somebody is not having it doesn't mean that it is not required. It might even be a violation, a non-compliance. So you have to follow the regulation, the law of the land. Okay, let's say that the rule says it, but you're not following it. As long as nothing happens, there is no problem at all. But if some form of accident, a mishap happens, then all hell is going to break loose. This is something that you have to bear in your mind. If you think by avoiding certain compliance factor you're going to save money, then when any mishap happens, then the consequences is going to be disaster. Whatever I'm explaining over here, I'm explaining in a very general way considering the existing regulation and the compliance norms. Following it or not is going to be up to you. Coming to utility, what is the power requirement? What is the load required for the machine operation? So accordingly you will decide your transformer sizing, your panel sizing. If there is a series of machine, then each will have different power consumption, power factor. So what is it going to be? Coming to water consumption, is there any such requirement? Then accordingly you will decide how much is the per day consumption. Is there a requirement for demineralized water, especially for chemical treatment? If yes, then what is going to be the water specification? So then accordingly you will decide on the water treatment. I'm not talking about wastewater treatment, I am talking about the incoming water treatment. Is there a gas requirement specifically for heating process? If yes, then what is going to be the gas bank sizing? Again, it's going to depend on the heating process, the timing, how much heat is required. So accordingly the capacity will be determined. Is there any heating process which require other than gas based heating? It could be oil based, electric based or coal based. So what is it going to be? Then coming to fuel, is there any fuel requirement apart from the power backup? These are some of the utility that your machine might require for the operation. How about manpower? How many workforce is required for the operation? If the machine technology or process is a little bit more sophisticated, then do you need technicians for the machine operation? Then you might need more workers for the floor, especially for the unloading part, loading part, operational activity. So what is it going to be? Again, it's going to depend on the nature of the process, technology or machinery. It's going to depend on the complexity, the nature. You should remember one thing over here. You cannot overestimate or underestimate. Whether it is the power, water, gas, fuel, workforce, you cannot overestimate or underestimate. If you're going to overestimate, it is going to eat into your margin. If you're going to underestimate, then you will have a problem in maintaining or running your operations continuously. So you need to have a very good strategy planning. How are you going to calculate what is going to be your average or what is going to be your required utility consumption, right, in terms of power, water, fuel, gas, workforce. Coming to the next aspect, consumables. It could be a one-time consumable or it could be a regular consumable. One time, which is generally required at the time of installation. It might be in the form of a civil work or civil alteration. Electrical wiring from the panel to your machinery. Again, it's going to depend on the machine load. The wiring size is going to change according to that. It has to run across the length and width depending on the position of the machinery and the electrical panel. For the water connection, then plumbing work has to be done connecting to the machinery. Wherever there is air and water pollution control devices, so there it is going to generate wastewater. even if there is a process which is going to generate wastewater, so that has to be connected to the effluent treatment plant. So what is going to be the sizing of the effluent treatment plant? So again, it is going to depend on the process. So accordingly, the size of the pipe is going to be decided, your incoming and the outgoing. To set the machine, you might require a hydra, a crane. Then only the equipment can be safely unloaded from the truck and placed in the respective position without any damage. If there is a air pollution, then you need to have air pollution control devices. Again, whatever is going to be the emission after treatment, it has to get released into the environment. For that, you need to have a ducting. The stack has to be there, which will go above the roof height. Again, the height is going to depend on your emission level. More is the emission level, more is the height required as per the norms. Is there a need for chemical? So then what is going to be? Is it going to be a one-off consumption or is it going to be a regular consumption? If it is going to be a one-off or regular, from where are you going to get it? Is it going to be provided by the supplier, or is it readily available in a local market? Or is there any special requirement needed from the government for any such chemical? Or you're going to get it from some other country. So what is it going to be? Again, it's going to depend on the quantity, the pricing, speciality, availability, and all these factors. Is there any other special tool that is required for the installation? Then you have to get it. If you think you're going to save time, money, then it's not going to work out. It is going to further delay your installation process. Coming to the regular consumables, it might be in the form of a tools, spares that is required. From where are you going to get it? Are you going to keep a stock of it? So how many such quantity you're going to get from your supplier? Is there any chemical consumables, any other consumables? So you have to factor in all of those things. After getting the chemical, after getting the machinery, if you're going to start thinking how you're going to get these consumables, the more you delay any dependency, more it is going to hamper your operation, more is going to be the delay. So whatever is going to be the resource, you have to plan well in advance. Of course, you have to follow a traditional approach, but then whenever you hit a roadblock, you have to go for an agile approach. It has to be a combination, a fusion of both. Then only you will be able to sustain and survive. Of course, you will hit some roadblocks. There will be some form of delay. It may be within your control or it may not be under your control. So you will be burning cash. So you have to factor and consider all those factors. So you should come up with a quicker remediation. How can you address the problem quickly? The more the delay is going to be, more is going to be your cash burn rate, and you will run out of money pretty soon. Then whatever is going to be a loss at that point of time, you may not be able to recover, because this is not a traditional manufacturing. You have a very tight margin. Your input and output are controlled by external factors. The only place where you have complete control is in terms of your resource planning, your capital investment, your operations. This is something that you have to bear in your mind. With that, we are closing today's video. I will see you next week as part of the Tech Tuesday, where I'm going to talk about the third R, the recovery or the output. I'll see you tomorrow with another video as part of the Waste Type Wednesday, where we are going to look at electronic waste.